All right, let's get into it. Today we're going to do away with the slides. We're just going to go right into a tool. This is a tool I've been using as a manager, as a director, as a CTO for about 15 years. This helps capacity plan your engineering team for work that they can do in any given sprint. And there's a lot of pressures, as we all know, going into a sprint, a lot of different priorities, a lot of different ways to think about where an engineering team could best spend their time. I think ultimately, as managers, we need to think about how to extract value out of every hour of an engineer that works for us. When we think about engineering capacity, or if we think about, let's say, a CEO thinking about the return on investment for an engineering team, there's two ways to think about it. The first way to think about it is, let's say an engineer, just for a round number, costs $125,000 a year. That means a team of 8 engineers would roughly cost that CEO $1 million a year in spend. Obviously, the number is usually a lot higher than that, but just for sake of math, we're using that as $1 million for an 8-person team. Now, if we're running at 50% capacity or 50% efficiency for an engineering team, the CEO might think, oh gosh, we're losing $500,000 a year of spend. This is not acceptable. So obviously pushing that number up to 100% of the capacity and efficiency an engineering team can produce in a given sprint or a given year is instrumental to saving that $500,000. But it's actually more than that. That number is actually on the smaller end of what you can save by seeking that efficiency for accounting for every bit of outcome that you can get from an engineering team. And what I mean by that is a CEO doesn't spend $1 million a year on an engineering team to get $1 million in value back. Typically, you're spending $1 million on an engineering team, hopefully getting somewhere around $5 million in value back. Which means that if you're running and you're not accounting for every hour and every day an engineer is working and getting the maximum output from that engineer, you're not losing $500,000. You're losing more like $2.5 million. So as an engineering manager, engineering director, as a CTO, this is the type of tool that I've encouraged my managers when I hire them and my engineers to use these type of tools to forecast what the next 2 weeks might look like. So there's two other kind of concepts, or at least one other concept closely tied, and that is the difference between accounting and the difference between forecasting. Accounting is basically counting things that have already happened or have just happened. So when you do a retro, or if you look at a burn down chart, you're basically accounting for things that happened in the past. And if you look at an accountant, a lot of what they've done is they've looked at money that is spent or resources that have been spent looking backwards. In finance, we look forward. We try to forecast spend. We try to forecast a return on investment. So this is a forecasting exercise, which I think is missing, a little bit more from the engineering culture than should be. There's a lot of accounting, especially looking backwards and maybe, doing some hand wringing on why did this project go wrong and this and that. We're always looking backwards. This is a wonderful opportunity to introduce the looking forward culture into your team. So I want to kind of go through why I think capacity planning is so instrumental, and if it's missing from your culture, why you should add it, because it's going to help you forecast the future better. So we're going to look at basically the simple sheet. The idea is that every sprint you have, you actually create a new sheet. You'll insert your company name, the name of the engineering team. So if you have a back-end team and a front-end team, or if you're on a two-sided marketplace, maybe you have your demand side team and you have your supply side team. However you've kind of carved up your teams, put the engineering team name here. This is for them. This is for how they're going to work and how they're going to collaborate together on this sprint. We quickly plug in the number of engineers. For instance, at Woot, I had 5 teams, roughly about 8 engineers each. Each one of them had a copy of this sheet, and they would use this at the beginning of every sprint to basically understand how much work they were capable of doing, understanding all the types of things that engineers were required to do on an everyday basis. I might also go to say that I find that if you don't have a tool like this and you start getting pressure from a CEO or you start getting pressure from your manager and they're like, why isn't the engineering team doing more? This is something I call showing your homework, where you can look back at the last 10 sprints, you can look back at the last 20 sprints, and you can say, this is exactly what the engineers were working on and why we allocated this much capacity or allocated this much to this particular project, because these were all the other things that we were also competing with as well. And that sheer act of showing your homework is, I guess, it can be considered defensive. Like, look, I've done everything that I can. But it also helps build confidence that you're on top of things, that you're thinking about everything, and that you could show throughout history that every day was accounted for in detail. And so, where you might say, hey, this is a CYA, could be, and at times it has been. Mostly this is about building confidence and trust. When you can show your homework at any time, and a lot of what I'm going to be doing through these future talks is giving you the tools where you can show your homework from the past to show and remind yourself sometimes, because sometimes you forget, last sprint was a long time ago, remember exactly what you were working on. All right, so we have a little legend. At any one time, an engineer could be available for work. They're getting paid, they're not on vacation, or they could be on vacation. Or they could be on call. If your team has a DevOps culture, which I hope it does, it's kind of like where most people are at these days, you typically have an engineer rotating on call throughout your entire engineering team. In my businesses and the companies that I've helped lead, on call is a dedicated function. Some companies do on call where it's a portion of time or they're expected to do some project work. I find most companies have enough operational load or operational burden and or technical debt that it's super helpful to have one person separate themselves every 8 weeks for an 8-person team or every 6 weeks for a 6-person team to focus on operational excellence, technical debt, key infrastructure improvements, stuff like lowering latency and improving CI/CD tools. They're basically doing work from the engineering backlog. And we're going to talk more about backlogs and backlog management in a future talk, including operational excellence. So stay tuned for that talk coming up. Either way, engineers in 3 states available for work, they're on call or they're on vacation, or at least that's the way it's used at my companies. Feel free to add another state or remove another state, but this is typically how it works. So you can drop your engineers' names in here. I just put engineer 1 through 8 for, how this works. Again, I've used this tool for about 15 years in various different formats, various different ways. I recreated it for this particular talk. So again, feel free to take this tool and modify it to how you'd like. And you can see this engineer number 1 has an X in their slot for these particular days. And that means that they're available for roughly 7 days of work. Wait a second. They're available every single day for work. Why are they only available for 7 days of work, this one engineer? Well, we have a discount over here. We call it a discount because we have to discount their capacity because they're allocated in other places with about 30% of their time. Most engineers at minimum are going to have 10% capacity that's going to be taken up by other things. It's one-on-ones with their manager. It's stand up every day, which is usually, hopefully 15 minutes. Maybe it could be 30 minutes. There might be a staff meeting every 2 weeks. There's probably some backlog grooming. There's some sprint demos. There's retro. There's sprint planning. So typically around 5 hours, 4 hours of an engineer's time is going to be carved out just for meeting time and collaboration time with their team, which means we have to discount 10% of their capacity, usually at the minimum, for those other kind of overhead pieces. And this gives us a truer look. In this case of engineer 3, this gives us a truer look that they really only have 9 dev days where they can sit down and focus on, doing engineering tasks. So why does this employee here have a 30% discount? This employee has a 30% discount because they might be in a position where they're heavily interviewing. Maybe they're one of the senior engineers and they're spending a lot of time interviewing. Maybe it's a senior engineer that is in a critical path for doing pull requests or code reviews just because they're very trusted in this particular area. And we can adjust this sprint by sprint. I usually ask the engineer, what's your discount for this sprint and why? And they say, well, Andrew, remember I have 5 hours of interviews over the next 2 weeks. I'm also working as engineering lead on this particular project. I have other cross-functional things that I'm doing, like potentially I'm meeting with some customers as a sales engineer. This discounts from or displaces other sprint work they can be doing. So already we're getting a truer look that engineer number 1 is only available for 7 days of work. If you put an O in one of these slots, it does not actually count them for project work. Again, this is just how I've run teams. You can actually set a 50% availability if they're on call, if you have low operational overhead, or if you have different team norms. By the way, I'll be doing a talk on team norms coming up here soon as well. But you can see that for this particular week, engineer 5 is on call, and for this particular week, engineer 6 is on call. And again, we get a truer look at their total amount to do work over this period of time. And this tallies up where, as a CEO, you might be thinking, I have 8 engineers. I have 80 dev days worth of work that can be done in this particular sprint. Well, guess what? You really don't. You only have 54.2 dev days because we've actually acknowledged that we have some discounts we have to give because there's engineers needing to be doing other things in kind of this general overheads bucket. We have engineers on vacation. I put a V here if they're on vacation. And that's going to reduce the amount of work that they actually can do. And we get a total of 54.2 dev days out of that 80 of where engineers can actually sit down and focus and do real work. So already just by doing what we've gone through so far, we've already been able to dispel a myth that 8 engineers are just available for 10 days of dev work every 14-day sprints minus the weekends. We're dispelling that myth and saying engineers are responsible for other things as well, like on-call and these overheads. Cool. So now that we know what our real capacity is, we're roughly at about 54.2 dev days of work that we can do this sprint. So we're missing about the 26 or 25.8 dev days of work due to other things that are important. Now we can think about allocation. Allocation is essentially something that you should work out as a CTO with your leadership team. There might be this big project that is got to be done by this particular time, so we're going to be setting aside 30% capacity for that particular project. Let's say a project is wrapping up and we don't really have that much work left to do. Maybe there's just a last little bug bashing or whatever might be going on. We're going to allocate 10% to that. And that will equate out to this project has 5.42 dev days we can do in the sprint. Whatever your priority number 2 is, perhaps it could be an integration with Okta or whatever is on your engineering roadmap that you need to do or your product roadmap, you can allocate 10.84 dev days. Priority number 3, 10.84 dev days. And you just basically sit with your leadership team as CTO and you dial, well, I guess we have to do 25% here to get 13.55 dev days to complete this particular project. But oops, we're over capacity at 115%. Something's got to give. So now we have a real tool to work with our stakeholders, hopefully our CEO, our VP of sales, perhaps our chief product officer, where they can sit down and look at trade-offs on where they want to place their bets. So kind of consider this like a roulette board, right? You have a minimum, a clear number of chips. You have 54.2 chips. Where do you want to lay those chips? And the great thing about going through an allocation exercise with stakeholders is they actively are participating and collaborating and therefore aligning on where those chips are placed. You never want to make this allocation decision unilaterally as a CTO or as an engineering manager. You always want to do it in collaboration with your stakeholders and your management team and or your leadership team. They will walk away satisfied that they made the right bet because they were part of the process to make that bet in the first place. Cool. So now we know that the next sprint, we should be allocating 13.55 dev days, 10.84 dev days, 16.26 dev days. Also, when I think about sprints, I don't think about the mandate or the need or kind of the goal being that we do 100% of every sprint as a commitment of what we do. If somehow miraculously every sprint, I say we completed every single thing that we did, every single thing that we intended to do, we completed, I might walk away with the feeling as a stakeholder that the engineering team is sandbagging it. And it's true. If you're finishing 100% of every sprint, you're not stretching yourself. You're not putting pressure on the team. Therefore, the real goal is to get somewhere between 85 and 95% of every sprint complete. It's great when you give it a try. You still don't want this to exceed 100%, right? You still want to say that 100% of our team has been allocated for. We've gone through the capacity exercise. We understand what the availability of each engineer was. We have well-groomed backlogs, and we'll get into backlog grooming and estimation in a later talk. But assuming that you have well-groomed backlogs that are well estimated, You can then just very simply in sprint planning, and we'll get into that again at a later talk, you can quickly grab the allocation as it is, which this case is 13.5 dev days. And however you calculate your sprint points, some people do it in dev days, some people do it on very complicated math. You choose how you want to do it. Either way, it likely maps into dev days at some point. All you have to do is drag out of that backlog, from that backlog, that ordered, well-groomed backlog, 13.55 days into the sprint, and your sprint planning is done for that particular priority. You drag in 10.84 dev days, maybe you can drag 11 in, that's stretching the team. 10.84 dev days, again, 11, maybe that's stretching the team. 16 dev days, might as well round that up to 17. Let's stretch the dev team a little bit. Maybe we'll end up at about 102% of our overall capacity that we're committing. Maybe some people will rally. Maybe the team will, find a way to do something a little simpler that might seem complex at first. But it's always good to stretch the team so you can get to that 85 to 95%. Either way, this is how I run capacity planning. This happens at the beginning of every sprint planning. This does, again, assume that you have well-groomed backlogs and they're well estimated. And we'll get to that in the next talk. Thanks for joining me today.